The most widely used method for finding out what parts of the brain we're employing when doing a task is called functional magnetic resonance imaging, or fMRI. Because the huge magnet you go into means anything metal would get sucked in too, filming close to a real machine is impossible. So to find out how fMRI works,
Okay, Alan, we're done. I can take you out now.
I tried out a fake scanner, courtesy of one of the world's experts in brain imaging,
Okay,
MIT's
here, let me help
Nancy
you.
Kanwisher.
That
Excellent.
noise is
How
very
was that?
convincing. What is this? You use this to get
This
kids
is called a
accustomed-
mock scanner. We
Yeah.
use this because we scan a lot of children, and we
Yeah.
want them to be used to the scanning environment.
When your brain is being scanned, what's going on in this functional MRI?
Okay, so each beep you hear is a picture that we're taking of a slice through your brain. And what's special about functional MRI is that the brightness of each part of that image tells us how much neural activity is going on in that part of your brain.
Why the brightness? What does the brightness have to do with it?
The basic idea is that neurons are like muscles. So if a part of your brain turns on, say right here, and the neurons start firing there, it's just like using a muscle. You need to send more blood to supply those neurons because it's metabolically expensive, just like running with a muscle. And so what happens when more blood is sent to that part of the brain is that the amount of oxygenated hemoglobin in that part of the brain changes. And that has a magnetic signature that we pick up with functional MRI. Your brain is a three-dimensional object, and we take pictures of it by making a series of slices, for example, like this. So we might choose, if we want to cover your whole brain, a series of 20 horizontal slices like this. And then within each slice, we have a nice 2D picture of what's going on in that slice. Each bang that you hear during a scanning
Yeah, those
sequence
frightening
is,
bangs.
is a little radio frequency magnetic pulse that we send in that it's like pinging on a wine glass. It reorients the hydrogen atoms in your brain, and the speed with which they come back to where they were is a measure of the amount of oxygenated hemoglobin in that part of your brain.
I understood some of that, but just enough to get scared. Now you have to unscare me.
Okay,
Because
so
if you're rearranging the hydrogen atoms in my brain.
You're just tipping them. It's no biggie.
It's like giving them a little nudge.
Yeah, they're precessing on an axis like this, and you just tip them a little bit. It's no biggie. It doesn't hurt.
I mean, I'm kind of aware in a general way that magnetism and electricity are part of the same phenomenon,
Yeah.
right? So if you're messing around with magnetism in my head, aren't you doing something electrical to me too? I mean, am I in
Yeah.
danger of? I'm being.
We are doing things, but we're doing
I'm expressing a fear that some people may
Yeah.
have, and I sometimes, when if I let myself think like this, I might have it too. So
Right.
so tell me about it.
Okay. It's true that we are disrupting the brain with magnetic and electric fields, but we're doing so in very subtle, small ways. And so I think the main reason to be reassured is that this method has been used for decades with no evidence of any problem. Animal safety studies have raised entire animals for their whole life while being scanned, with pregnant animals, rats raising pups inside a scanner with no problem. And if it's a more direct reassurance, I have very close to the world record, probably not the world record, but very close myself for total number of hours spent in there. Hundreds of hours, and I haven't noticed anything. Maybe you should ask my colleagues.
I got to look you up in Guinness. This is great.